What an introduction. Thank you very much. I'm super excited to be here. The conference organizers have been wonderful to us so far. Someone came and picked me up from the airport at 3 a.m. Like, that's not normal for these types of conferences. Let me check now. I'm here to talk about TypeScript, as you can probably imagine. And my name's Matt. I talk about TypeScript for a living now, which is kind of strange. And you can find all my stuff at totaltypescript.com. And in the spirit of kind of looking at stuff again, understanding stuff from a new perspective, I want to talk about a weird title. There is no such thing as a generic in TypeScript. I think what Ben's talk really showed me is that language matters. The way that we describe our code, the way that we understand concepts really matters. Because, I'm just going to get my water, by the way. If we don't use the right language, then we can get the wrong thing in our head. And I think that the phrase generic is incredibly overloaded when we talk about TypeScript. There are several phrases that you'll hear TypeScript people talk about that I don't think are really right. Now, before I carry on, though, who uses TypeScript? Raise your hand if you use TypeScript. Yeah, OK. Raise your hand if you don't use TypeScript. Yeah. And keep your hand raised if you know why you should be using it. Yeah, OK, cool. So I don't need to sell you on TypeScript. You all know the reasons TypeScript is good. And the bits of language that I don't think are quite correct is people will say, OK, you can pass a generic, right? You can declare a generic. You can infer a generic. Or there's a list of generics here. And I want to tell you that I don't think these are quite right, because generic is an adjective, not a noun. This sounds like extremely pedantic. This is like, why is this guy talking to me about this language? But I think it's key to understanding the whole concept. And you might be thinking, this sounds like wizardry. Why should I care about generics at all? What's the point in me understanding this information? How is this going to benefit me? How is this going to make my code better? How am I going to get a job with this? Well, you might think, you're working in apps, right? And when you're working in apps, the TypeScript you need to write isn't that hardcore. You're just writing pretty simple TypeScript, and often you're consuming things from libraries. And the libraries are where all of the scary TypeScript happens. And this is true, right? It can be really intimidating looking at code in a TypeScript library. Ben knows this, in RxJS. Anyone who's worked on a library can be terrified by that code. And in general, the structure kind of looks like this. You've got your libraries where the scary stuff happens. And because the scary stuff is happening in there, you don't need to worry about it in your app. Fantastic. So most of the time, if you're working on simple things, the app is just going to be pretty relaxed in terms of the level of TypeScript you need to write. You don't need to worry about generics. You don't need to worry about any of the sort of crazy inference things. Even like casting, you don't need to use any that much. It's all pretty chill. But then your app gets bigger. And when your app gets big enough, or you're working on a code base that's big enough, you'll start to notice that you actually have this kind of pattern where you have a lot of shared code. And when that shared code comes in, that shared code now needs to talk to more things, needs to be understood by more things and used in more places. And so we end up with the same pattern that we had before, but now it's in your code base, right? It's there. And usually there's just sort of one or two TypeScript wizards on your team who understand how this stuff works, Like, please, Brian, can you just look at this function again, because I have no idea what it's doing. This terrifying thing, which you look at in your code base. And here's my promise to you. By the end of this talk, you will understand what this function does. Now, this is a pick function. It's a function which is basically just a function, guys. It's got a reduce in there, and it creates a new object based on an object that's passed in, and then an array of keys that you then pass in. And you might be looking at that and thinking, yeah, OK, I understand the bit sort of between the curly braces. That all seems OK. There's a couple of scary TypeScript annotations in there. And the thing you're probably most scared of is this bit up there. Yeah? So this bit up there. Now, the people who have looked at a bit of TypeScript might be thinking, OK, those are generics. I understand that. There's a generic there, t-obj, this one here, inside the angle braces. T-obj, that's the first generic. And this one here, Second one, that's another generic, right? These are generics. Well, there's no such thing as a generic. I want to break this down into a couple of different concepts. And instead of calling these generics, I would say that this is a generic function, and these are type parameters. So, you have, in TypeScript, generic types and generic functions. And we're going to cover both of these, and we're going to break them down into exactly what they're doing. Let's start with generic types, once I've had a sip. So, a generic type, really, is just a type that takes in another type. Let's say that we have a user type here. And we have a couple of properties. We have name and phone, which are string or null or undefined. And imagine this is like 10 properties long or something. Let's say that we want to reduce a bit of this duplication here. We've got null or undefined in both places. So we create a maybe type, which represents null or undefined. Now, we can replace the null or undefined with our maybe there. And we've reduced a bit of duplication. But this feels a little bit funky, right? It doesn't feel quite right. Maybe feels like a descriptor. It feels like we should be saying this is maybe a string instead of string or maybe. So how would we do that? Let's take our maybe type, and let's add a type parameter to it. Now this is called t, but you can call it whatever you like. And this is valid syntax in TypeScript. Works great. Now we can take that t, and what's going to happen now is when we use this maybe type, it's going to require us to pass in something for t. And so we better use that t. And so we now make it part of that union. So if we put string into this maybe, if we pass in a type argument into this generic type, then that's going to end up in that union. So that means we can go back to our user type, and instead of string or null or undefined in both places, we can now say this is maybe a string. Very nice, very pretty. Look at that. It's now capturing this inside a sort of reusable function. And so you can think of these as type functions. And the thing that we're passing into the generic type is a type argument. So up at the top, type maybe with a t, that's a type parameter on a generic type. And these are type arguments that we're passing in. And let me hammer this home. This is just a type. It's like a variable in JavaScript. This is a generic type that receives a type argument. So no type parameter on the type, and a type parameter on the generic type. That's the only difference. And so this is kind of like the difference between a function syntax and a variable syntax. So generic types are type functions, and this means that they're useful in all of the ways that normal JavaScript functions are useful too. You can make reusable parts out of this to be really expressive with the way that you build your types. Let's take a look at an example. Let's say we've got a response shape type function here, which takes in another t. Like, people love using single letter variables for these. Like, these are just everywhere, and I quite like following them as well, but apologies if they look a bit weird. So you take this, and you can basically pass in anything into here, so you can pass an object. And so this response shape now, it receives or is being passed in name string and age number. And this is a type argument being passed in that will end up in a response shape where that object is now being put on the data. So again, you can reuse this hundreds of times across your repo, and like it will always produce the same result. Very, very useful. And what happens, though, if we remove that type argument? What's the behavior? What is TypeScript going to do? Well, it's going to yell at us. TypeScript requires, by default, that you pass in all the type arguments. And this is really key to understanding the whole thing, actually. And we can kind of like default that t up there. We can use like an equals undefined or something, but you can check the TS docs for that. But the main idea here is that generic types require type arguments. You must pass in all the type arguments into a generic type. You must do it. And this is different to something we'll look at in a minute. So that, on a basic level, is all you need to understand about generic types. Like, you can create types out of them. They're pure. They don't do anything, no side effects on the side. And they act like type functions in your code base. Super useful. Let's talk about generic functions now. Now, generic functions are more prevalent than you might think. This is a set. We are creating a set here, and a set is a set of unique values that we can iterate over. And so this set, let's say we add a string to it. We say set.add hello. And actually, we want this to be a string set. We want to only be able to add strings to it. But what happens if we try to add a number to it? Well, TypeScript is not going to error here. It's not going to care that we're passing in a number here, and that feels really weird. Surely when we add a value to it, it should understand and do its thing. Well, the issue is that set at the top, we're not telling it through any mechanism what type it's supposed to be. There's no information for TypeScript to understand what the set is supposed to contain. So we can pass a type argument to that function. It turns out that set is a generic function that can receive type arguments. So that's all a generic function is. It's just a function that can receive type arguments. And now we're going to get an error here because it's saying, okay, I understand this set should only contain strings and this number is not a string. Very cool. So this is nice, and this is the type argument being passed in. So generic functions, you notice, don't require type arguments. You don't need to pass in all the arguments here. There was a version here without this type argument being passed in. So that's a crucial difference. Generic types require type arguments. Generic functions don't require type arguments. But how can that be possible? Why is that going to be useful? Well, yeah, here we go. I can't remember what the next slide is. I'm just going to go for it. Okay, cool. So what happens then if we pass in a type argument and a runtime argument? Here we're passing in a type and a value. The value here we're passing in is an array of A, B, C. We're passing into set. And this is something you can do with sets. You can provide some initial values. Well, this is good. We can add more values to this. But when we add a number to this, of course, we get the same behavior because we're passing in the type argument. But what happens if we remove the type argument? This error still stays there. What? How can that be possible? We have lost information on that set. We're telling TypeScript less, but we're getting the same behavior as when we just use the generic function without passing in a type argument. Well, for that, we need to look at some slightly scarier code. This is the type definition for sets in TypeScript. This is a slightly simplified version. The other one contains some sort of interfaces and weird stuff, but this is essentially the core of it. So what we have here is a function definition in TypeScript that has a type parameter on it. So if we didn't have this type parameter, it would just be a normal function. Okay? This is a generic function. And that type parameter is being referenced inside the values here. So the values there, that is the type parameter being referenced. And then at the end, the function spits out a set of that type. So when we pass in string into that first little slot there, it's going to basically use that as the set that's coming out at the end. So here's the thing. Let me go back. When you specify a type argument being passed to a generic function, that becomes the source of truth. So that is the thing that you say, okay, I'm telling it to be a string. And this means that if you were to, let's say, add in a number into this set here, this would error. Because it says, okay, you told me this was a set of strings, but you added in a number, you idiot, what are you doing? So that becomes the source of truth. But we don't need to pass in an initial value here. Don't need to pass in an initial type. So what happens if you add a number into there? Well, this then becomes the source of truth, the source of inference. If you add a type argument, that's the source of truth. If you just add runtime values, then the runtime values are the source of truth. And so you end up with a set that's a string here. And if you add in a number into this, it's not going to error. It's going to actually just add that to the thing that's possible in that set afterwards. So generic types do require type arguments. And generic functions don't require type arguments. And if they don't receive type arguments, they will infer the type from the runtime arguments. That makes sense? Nice. So this now, there is no source of truth, there's no stuff being passed in, so it attempts, if it can, to resolve the type from the runtime arguments being passed in. And this is the source of basically all of the TypeScript magic that you'll see in libraries like Zod, libraries like tRPC, even in React and stuff. So let's go back to the scary piece of code. You might be thinking now, okay, I'm starting to understand a little bit more. This is a generic function, right? Let's look at a usage example just so we get the full picture. At the bottom here, we have a pick that we're calling with an object with A and B, and we're picking A from it. So this tObj at the top here, which is the type parameter, is being basically referenced here in the runtime arguments. And in this instance, we're passing in this object. Cool. So that means that tObject is going to be inferred as A and B, or rather an object containing A and B. Then we've got another type argument or type parameter at the top. tPicked extends key of tObject, and this means that it's basically constrained to be the keys of that object that was first passed in. This is referenced inside this runtime argument, and then down here it's going to be inferred as A. If we passed in A and B, it would be inferred as A or B, because those are the members of the array. So this means then that the results now, this is going to be inferred as pick tObj tPicked. And pick is basically a TypeScript native way of saying pick just these keys from this object. And so you end up with the results being inferred as pick A number, B number, and pick from it A, which resolves to A number. Beautiful. Just beautiful. So does that make sense? Nice. And this, from a consumer's point of view, if you think back to like the library code and then like being consumed by the apps, this is pretty nice, right? Really, really nice from a user's point of view, because you don't need to provide any type arguments there. So this is the really powerful thing about generic functions, is that the people using the generic functions don't really need to know that much advanced TypeScript. So by building out this sort of complicated type definition up there, you are saving a ton of work and ton of type definitions down the line. Because otherwise, we would have to, if this pick function was just really thick, sorry, British for stupid, you would have to actually manually assign that type, which could be dangerous because TypeScript doesn't know whether the thing that's returning from that actually corresponds to that, and so it would result in bugs down the line. And so by making this complicated type definition, you're really making your app a lot safer. So generic functions. If you don't pass in a type into a generic function, it will attempt to infer the type from the arguments. Language matters, right? If you were to think, look back at that complicated piece of code and thinking, okay, or even this piece of code and say, okay, we have a response shape which is a generic type which has a generic up there. Inside response shape, we are passing in a generic to this generic type and getting back, it's inferring the generic from the generic slot or something. It's just nonsense, right? It just completely melts your brain. We're assigning too many concepts onto the same word, and it just kills you. Up here, we have a generic function with a generic of tObj, a generic of tPicked, which relies on the generic of tObj. We're referencing the generic inside tObj, and then we're returning a generic type. Oh, my God. So think of it in terms of these ideas. We have generic types. We have generic functions. We have type arguments, and we have type parameters. And there is no such thing as a generic. You can keep the term generics, I think, probably. The TypeScript docs say generics on them. I think the generics page on there is awful, actually. But yeah, don't use the word generic as a noun. It is an adjective. And if you want something to reference here or something to remember this by, I've got an article on totaltypescript.com, which is basically what I stole this talk from, called No Such Thing as a Generic. So make sure you reference that and use that, because that's, it explains it kind of quicker than I could. And I've been Matt Pocock. You can look at all my stuff on totaltypescript.com. We've got 10 minutes left. Let's do some live coding. Let's check this out. Thank you. Thank you, thank you, thank you. Okay, so I'm writing a book on TypeScript, which is very fun. And in the course of this book, I've come up with, what are we at? Yeah, this is 223 exercises. Oh, God. Which is a lot of work. But let's look at one of those exercises now. And this is kind of a simple one on generics, really. So we have some code here, which is basically it's a reusable function to create a string map. And we've got some tests down below as kind of usage examples. So this one here, we're supposed to be able to create a string map, passing in a type argument, and then we set some values in there where the key is a string, which is foo, and then the value corresponds to that number. And if it doesn't correspond to that number, then we should be getting this, by the way, this TS expect error. It expects an error on the next line. If you hover over it, it's going to say unused TS error directive. Thank you, TypeScript, for your lovely error messages. I need to add a translation to that, actually. Damn. Okay. So how do we do this? What are these errors that we're getting here? And there's a couple more down below. This one is you should be able to grab in a number there, or rather an object containing a, which is a number. And if we hover over these errors, it's saying expected 0 type arguments, but got 1. You notice that TypeScript is using the same language that we were just using. So it's saying, why did you pass in a type argument? Because this generic function doesn't want a type argument. So we need to give createStringMap a type parameter. And just for fun, let's just call it tValue here. Okay? Cool. That error has gone away. Very nice. So createStringMap now is happy, and you can even see that when you hover over it, it's sort of got number inside the angle brackets there. Lovely. But we've still got some errors here, because object.mapSet here, if we look at this, we've got a map thing that is basically, you can see the angle brackets inside, and it says any in there. So you can see that map actually wants to receive a couple of type arguments. So map is in itself a generic function. So let's look at map. You can see map constructor. It's got map any inside the angle brackets. So you can use these VS Code hovers that I'm showing you, or any IDE will show you this information, and look at the angle brackets, and you can see what type arguments, what type parameters are on these functions. So now that we're accepting tValue here, which on createStringMap is a number, we can use it inside this code here and pass map its own type argument. So map, I happen to know, it requires the key as the first type argument, and then the value as the second type argument. And it's really weird when I'm talking to you about this as well, because I'm really this talk is like a reference for me to stop saying the word generic, because I really want to say to you, okay, you pass in the first generic into map, and it takes another generic, so it's a learning experience. So map takes in the first element, which is this key, and you can see now that it's saying, oh, here we go. No overload expects 1 type arguments, but overloads do exist that expect either 0 or 2 type arguments. Okay, so what it's saying is, why did you pass me 1? You should either be passing me 0 or 2. So we need to pass in a second one. And the second one we'll pass in is this tValue. And now, just like that, we've taken that type argument, we've put it into the type parameter of another generic function. So it's like we're currying one from the other. And now the thing that we get back, instead of being map any, is map string number. If I change this to Boolean, for instance, then this becomes map string Boolean instead. Does that make sense? Nice. We've got time for one more? Yeah, let's do it. And now, whatever we pass in now, by the way, just to really hammer this home, this then gets put into all of the methods of the map too. So if we hover over this set function, you can see that this is a map string a number, and when we set it, we have to set a key of string, and the value has to be a number there. Super duper nice. Okay, let's do this one. Unique array. This is quite a common method that you'll see in lots of different util libraries or things like this. What we're trying to do here is we're trying to say, okay, I want to pass in an array of stuff and then only get the unique members back. So if I pass in a bunch of like 1s and 2s and 3s and stuff, then I should get back 1, 2, 3, 4, 5, because those are the unique members. How do we handle this? You notice that when we call unique array here, we're not passing in a type argument, but we do require a runtime argument. That runtime argument is all of these numbers here. Now we could pass in anything, right? We could pass in a bunch of strings here, and this line here is basically saying this result type should be of type string array, but instead it's any array. How do we do that? Well, let's think about this. If we wanted to make this a generic function where we specify the type argument at the start, we would probably need to be able to pass in a type argument here. So we'd need to say unique array passing in a type argument of number. So, but we're getting the same error here, expected 0 type arguments but got 1. So we need to add a type parameter onto unique array. Let's go for t, because, feels like home, I like it. Now this t then, now this has gone away, but it's not actually being referenced anywhere. You can see that it's slightly grayed out, if you can see that, and it's actually, if we hover over it, you'll see it's an unused, it's declared, but its value is never read. So you get the same actual inference that you do on JavaScript in TypeScript. So we need to actually use it somewhere. And what we can do is we can use it in array tArray. So now that we've referenced it, this is going to start working. And if I go down to this string one down the bottom, which is unique array passing a bunch of strings, you can see that when I hover over this, this has string being inferred in that type parameter slot. Fantastic. So this is really, really good if you want to check what TypeScript is inferring that parameter as. If I add in a number here, and if I look at this, it's going to say string or number instead. This is kind of a way that you can debug your own generic functions and understand what's going on. And of course, if I go back to the top here and I say unique array number, I can remove this, because now this is actually useless information. This is telling us nothing, really. I can remove this, and if I still hover over it, it's going to say number 2. So I think one thing that I want to point out here is that the instincts on when to make a function generic are something that you kind of have to build up over time, I think. By looking at this stuff and understanding, okay, I really need like the thing that I spit out here to be dependent on the arguments I pass in. We noticed that unique array, before it was just like an array of any, like this. And what this means, if I just remove this guff, sorry, another guff, Britishism, means stuff. Here, this means now that whatever I pass in, I'm going to get the same thing back. And it's going to be an array of any, which is not particularly descriptive and can kind of harm your type safety. But if I know that the thing that I'm getting back is dependent on what I'm passing in, then you're going to need a generic. Bugger. No, you're not going to need a generic. You need a type parameter. Oh, no. See, I told you I'd mess up. But I hope that that was useful, and I think I'm out of time, so thank you so much, everyone.